Okay, 8.6, sketching planes in R cubed. So sketching a plane in R cubed can be created by using a combination of points and lines that help define the plane. So to sketch the graph of a plane, consider each of the following cases as it relates to the Cartesian equation, which we just learned, ax plus by plus cz plus d equals 0. Okay, so here's case 1. Okay, and we'll reference back these cases. The equation contains one variable. Okay, so in this case, two of the coefficients, so two of either a, b, or c equals 0, and d equals 0. Okay, this is what happens. So if x equals 0 is the coordinate plane yz plane. Y equals 0 is the coordinate plane, like the xz plane. And z equals 0 is the coordinate plane, the xy plane. Okay, so this is if d equals 0. Now, if d does not equal 0, but two of the coefficients a, b, and c equal 0, what we're going to end up having is ax plus d equals 0, or by plus d equals 0, or cz plus d equals 0, right? Because a would have been 0 to the coefficient, so like it'd be like 0x plus 0y, essentially. So those would go away, they'd cancel out, and we're left with cz plus d equals 0, just as one of the examples. Okay, these are parallel to 3 coordinate planes. Okay, what that means is that we learned that this d value distinguishes one plane from another. And that's going to be the distinguisher about whether or not, say, for example, two parallel planes lie on top of one another or are parallel. Okay, so coincident or not coincident, right? And it depends on, basically, like if you can think of it as kind of like a height, even though it could be in the x, y, or z direction, you can think of it as, okay, you can think of it as like the number, like the height that it lies at. Okay, it's not always going to be horizontal, but just to conceptualize what D actually means. Okay, just change this so that I can follow this up with a question that uses this case. Okay, draw the planes with these equations. So plane 1 is going to be x equals 5. Okay, so let's talk about that. So we're going, let's just call this A. So plane 1 x equals 5. Okay, so we're going to have the x, y, and z axes, okay? And we draw the positive axes. So x coming toward us is going to be the positive x-axis. Y going to the right is going to be the positive y-axis. And z going up is going to be the z-axis, okay? So if we're plotting the point x equals 5, we're going to locate 5 on the x-axis. And it's going to be the plane going through x equals 5. So up here in this case, we had x equals 0. So here's the thing. We actually have for our question x equals 5 as the plane, right? All that does is it takes our coordinate plane from like our YZ plane, and it moves it forward 5 units in the x direction, and then we replot it. So this YZ here in the background here, this would have been our coordinate plane for YZ, and again, we just moved it forward. Okay, the second plane. So plane 2, y equals 6. Okay, so I'm going to go ahead and draw the positive x, y, and z axis. Okay, this is going to be B, so plane 2 is y equals 6. Okay, so y equals 6. So this is going to be very similar to this explanation here. Instead of y equals 0, we have y equals 6. So instead of being the xz plane, so the xz plane would be here, right? What would happen is we're going to do something parallel to the xz plane, and we're going to go in the y direction 6 units. So say 1, 2, 3, 4, 5, 6, say 6 is here. Okay, and then this is our new plane. This is going to be our plane y equals 6, right? And the last one, so for C, we're going to do the third plane, oops, doing equal signs, z equals 6. Okay, so again, I'm going to draw the x, y, and z axes. Okay, and change color. So x equals 6, or sorry, z equals 6. Okay, if we had z equals 0, it would be actually like the xy plane. So xy, this plane would be here. Okay, and again, planes go in all infinitely in all directions. We denote it with a rectangle still or a parallelogram. Okay, and what we're going to do for the z equals 6 is we're going to move it in the z direction 6 units. So let's just move that up to this number, which is 6. Okay, and that is our plane z equals 6. Okay. Okay, so for these three planes, let's write a prescription or description. Okay, x equals 5. We said that this is parallel to the YZ plane. Okay, and if you think about it, like the x-intercept is 5, 0, 0. Okay, so generally x equals a, whatever the a value is also going to be parallel to the YZ plane. Right? We originally had it as the YZ plane is x equals 0. So now a is just going to move it in the x direction a units. Okay, and then generally the x-intercept is going to be a 0, 0. Okay, for the second plane, y equals 6. This is going to be parallel to the, okay, see how we have a y here? It's like the other two letters. So the xz plane. Okay, and it's not going to be the y-intercept this time. It's going to be, or sorry, the x-intercept this time is going to be the y-intercept is going to be 0, 6, 0. So the generalized form of this is going to be y equals some letter, let's call it b. Okay, and that's going to be parallel to the xz plane. And the y-intercept in general is going to be 0, b, 0. Okay, and the last one, since we have a z, this is going to be parallel to the other two letters, right? xy plane. And now the z-intercept is going to be, this time it's going to be 6, so 0, 0, 6. But if we're going to generalize it, then we're going to have z equals some number c, and it's going to be parallel to the xy plane. And then the z-intercept is going to be 0, 0, 6. Okay, now case 2, the equation contains two variables. Okay, so one of the coefficients, so one of either a, b, or c equals 0, and then d equals 0. So we're going to have an a and a b but no c, a b and a c but no a, or an a and a c and no b, right? Obviously b equals 0. This one would be a equals 0, and this one would be c equals 0. Okay, and then of course all of them d equals 0. So find a point with missing variable set equals to 0, and join this point to 0, 0, 0, and draw a plane containing the missing variable and this point. Okay, this is used in example 2. So let's embed this. Sketch the plane defined by this equation. Okay, so we have some plane defined by 2x minus y equals 0. Okay, so this is going to be case 2 because we have d equals 0, and see how we have an x and a y? The z is also going to equal 0, so c equals 0, right? Like, so z like there's going to be no Z value. No Z value. Let's throw that in there. Okay. So we can say, because we have the 0Z, it contains the Z-axis. Okay, and what it's going to do is it's going to cut the XY plane along the line. Okay, 2x minus y equals 0. Okay, because if you think about it, we have now a line that they give to us, and we have like two variables. Okay, so we can actually rearrange this so it's in the form y equals mx plus b, right? If we bring this over and we have 2x equals y, then our slope is 2 and our y-intercept is 0. Okay, a couple more things. This is going to contain the origin. Right? So the point 0, 0, 0. So all we need to do is we need to find a point to satisfy 2x minus y equals 0. Okay, so we can plug anything in here. So let's just simply plug in. So we know that the z is going to be 0. So let's just plug in a 1 to x. Okay, so these two equations are the same. So I'm actually just going to plug it into here. So 2 times 1 equals y. So we have 2 equals y. So our point is going to be 1, 2, 0. Okay, so let's draw our positive x, y, and z axes. Okay, and we're going to plot the point 1, 2, 0 first. Okay, so 1 is going to be in the x direction. 2 is going to be in the y direction. Okay, and then we know z, we're going to actually contain the z-axis. So this entire axis we're going to contain. Okay, so this right here would be our point. Okay, so we're going to draw a line from the origin, because we're going to contain the origin as well, to the point 1, 2, 0. Right, this is 1, 2, 0. Okay, so I'm going to do this one in green. So we're going to contain the z-axis, we're going to contain the origin, we're going to contain this point, and then we can draw this as our plane. Okay, so the point from 0, 0, 0 to the point 1, 2, 0, this is going to represent like the angle of the plane that the plane's like leaning at. Okay, and it's going to represent the y equals 2x, that line. Okay, so this is our plane. All right, example 3, write the descriptions of these two planes. So we have, let's chunk these into A. So we have plane 1, which is 2x minus z equals 0. And then B, which is plane 2, y plus 2z equals 0. Okay, so this the same thing as above. Okay, so this time we have 2x minus z. So you got to think about it. So first of all, d equals 0 here. We don't have a constant value. Okay, and then the other thing is that we don't have a y value. Okay, so the b value equals 0, right? So like y equals 0, no matter what. So because we have y equals 0, this one's going to contain the y-axis. Okay, and this is, again, this is basically linear. So we're going to cut along the line 2x minus z equals 0. Again, we're going to include the origin. Okay, so let's plan a point to satisfy this. So I'm going to actually bring this over, and we're going to have 2x equals z. Okay, so very similar to the last one. But in this case, I'm going to actually delete this, and we will move this over. That's fine. Okay, so in this case, let's find a point. Okay, point to satisfy Okay, if you think about it, we're going to have a 0 in for the y no matter what. So let's just plug in a 1 for the 2. Okay, so a 1 for the x. So 2 times 1 equals 2. So we're going to have the point 1, 0, 2. So let's think about this. Okay, we're going to draw the x, y, and z axes. This time we are going to contain the y-axis. So we're going to contain this entire axis right here. Okay, we're also going to contain the origin. And now let's plot a point at 1, 0, 2. So this is x, y, z. We're going to go 1 in the x direction, 0 in the, x direction, 0 in the y direction, and 2 in the z direction. Okay, and we're going to plot a point where that is. Okay, so let's connect the origin with our point. Okay, so the origin is going to be our 0, 0, 0, and our point is going to be 1, 0, 2. Okay, so all we have to do is draw a plane that contains the y-axis, which this does, the origin, and this point. Okay, let's do B. So the second plane, y plus 2z equals 0. Okay, so we can clearly see that d equals 0 and our a value equals 0, which means our x equals 0. Since our x equals 0, our plane is going to contain the axis, the x-axis. Okay, we're also going to cut, because this is a line. We're going to cut along the line. Okay, it's going to be y plus 2z equals 0. But if we were to bring over maybe the 2z, let's do that. We're going to cut along the line y equals negative 2z. Okay, we're going to include the origin again. And let's pick a point to satisfy. Okay, so already we know that our x is going to be 0. So let's just plug in a 1 to where the, you know what, let's plug in a 1 to where the z is. And that's going to be the easiest thing. Okay, 1, and then we have y equals negative 2 times 1, which is negative 2. So the point that we're going to use is 0, negative 2, 1. So let's draw the positive xyz axes. Okay, xyz. Okay, we're going to change color. We are going to contain the origin. We are also going to contain the x-axis. So we're going to contain this axis here. Okay, and we are going to cut along the line, but we don't really have to focus on the line here because we are going to join the origin and 0, negative 2, 1, and that's going to satisfy that. Okay, so 0 in the x direction, negative 2 in the y direction. So the y direction, because we're going in the negatives, we're going to go back here. That's going to be negative 2. Okay, and then we're going to go 1 in the z direction. So this is going to be 1. So this is going to be our plane like this. Okay, remember that's going to cut over here. It's going to go on forever, right? Okay, so we're going to go back to case 2, and we're going to do the situation where d does not equal 0. Okay, so the equation contains 2 variables. So one of the coefficients, either a, b, or c, is not in the equation. Okay, so those equal 0. But this time we have that d value. Okay, so it's going to be about the same idea, but we're just going to shift the entire plane. Okay, so we would have an ax plus by plus d, so the c would equal 0 there. We have a b, a c, and a d, so the a would equal 0 there. And then we have a, c, d, so again, the b would equal 0 there, okay? So what we're going to do is we're going to find the 2 intercepts and draw a plane parallel to the missing variable axis. Okay, so let's embed this directly into a question. So find find the two intercepts, and we're going to draw a plane parallel to the missing variable axes. Okay, example 4. Sketch a plane defined by this equation here. So we have plane 1 being 2x minus 5y minus 10 equals 0. So we can see off the bat that we have no z value. So z is going to equal 0 there. Okay. So let's first find the x-intercept. So in order to find the x-intercept, we know that we have to sub in y equals 0. So let's go ahead and do that. 2x minus 50 minus 10 equals 0. By substituting in y equals 0, we no longer have this negative 5 times 0. Okay, we have 2x equals, bring this negative 10 over, we get 10. We get x equals 5. Okay, so that's going to be one of our intercepts. We're going to have the x-intercept 5, 0, 0. Okay, now let's talk about the y-intercept. In order to find the y-intercept, we sub in x equals 0. So let's go ahead and let's sub in 0 for the x. So we get 2 times 0 minus 5y minus 10 equals 0. And this value goes to 0, and we're left with negative 5y equals, bring the negative 10 over, and we get 10. Okay, divide out the negative 5, and we get y equals negative 2. So our y-intercept is 0, negative 2, 0. Okay, so going back up here, find the two intercepts. So we got that. And now we're going to draw a line, a plane parallel to the missing variable axis. Okay, so I'm just going to make a note right now. So we have, so the z-intercept would be, okay, in any other question, it would be the point at 0, 0, z. Okay, so you would do the exact same thing for like the z-axis if it had two variables and z being one of them. Okay, but so subbing in this, the equation technically, like mathematically, would be, so if we had 2x minus 5y plus 0z minus 10 equals 0, okay, if you actually think about it, like if we plug in 0 and 0 for both the x and the y, and then the z is already 0, and then we'd have negative 10 equals 0, what would end up happening, I'm going to leave that plus 0z minus 10. I'll leave that in. Okay. So what ends up happening is this goes to 0, this goes to 0, and we would have 0z equals 10, right? Bring over the negative 10, we get 10. Okay. Let's think about this. You cannot sub any number in to the z in order to yield 10. So that's inadmissible. That doesn't exist. Okay. It's undefined. So therefore, there's no z-intercept. That's how you can prove it. That satisfies. So we're going to actually be parallel to the z-axis. All right, now let's go ahead and graph. So I'm going to put the graph here so it's nice and big. Okay, we're going to graph again. Start by drawing the positive x, y, and z axes. Okay, I'm going to do this in a red color, burnt orange. Okay, so let's talk about this. We are going to draw, say this is 5. This is going to be our our x-intercept. Okay, 0, negative 2, 0 is going to be our y-intercept. So again, we have to go here and draw. Maybe negative 2 is going to be here, okay? So we're going to get negative 2 in the y direction, okay? And then remember, we're not really going in the z direction. We are going to be parallel to the z-axis. So what we would do is we would draw I'm going to do this more on an angle. Let's do this -2 here because it's going to be easier to see if I can do this more on an angle, okay? So we're going to draw a line between these 2 points, right? The x-intercept and the y-intercept, and then we're going to go parallel to the z-axis, okay? The z-axis is obviously going vertically, so we're going to just draw our plane parallel to that. Okay, now, case 3, the equation contains 3 variables, okay? So again, under this case, there's going to be 2 situations. So first, if it contains 3 variables, none of the coefficients of a, b, or c equals 0, okay? And we're going to have the first situation where d equals 0. Okay, so we have the entire equation except for we have a plus 0 in here, right? Like there's no d value. So we have ax plus by plus cz equals 0. So what we're going to do in this is we're going to determine 2 points in addition to the origin, and we're going to draw the plane through these points. That's it. Okay, so let's do an example of this. So we have example 5 here. Sketch the plane, and then plane 1 is x plus 3y minus z equals 0. Okay, so we see that z equals 0. So there's no constant. Okay, no constant. Okay, as soon as we see that there's no constant, we know that 0, 0, 0 is on the plane. Okay, so we need 2 points. Okay, so we need 2 points. Okay, so let's talk about point number 1. Okay, point number 1. So we can do something like the xy plane. So z equals 0. Okay, so if we did that, we would have the equation x plus 3y equals 0, right? Like if we substituted z equals 0, we would just get rid of that z value. And then what we can do is we can select a point that satisfies this equation. So if we already substituted in z equals 0, we would just need 2 more points. So let's just substitute a 1 in for, let's go y. Yeah, because if we were to bring this, if we were to bring this one over, I think that if we had x equals -3y, that's going to be the easiest. So let's substitute in a 1 in for y, and we're going to get x equals -3. Okay, so that's one way to choose a point. And now for point 2, we can do the same thing, but let's do the xz plane. Okay, so in this case, y equals 0. So what we're doing is, so by substituting y equals 0, we're going to get a 0 here, and we're going to get x minus z equals 0. Okay, if we bring that over, we have x equals z. So let's have a point satisfy this. So the y is going to be 0. And then if we substitute 1 in for x, we're going to get 1 for z. We could have 2, 2, 3, 3. Okay, doesn't matter, but we chose 1, 1, so that's good. So let's actually go ahead and draw this. So we're going to draw the positive x, y, and z axes. Okay, we're going to plot all 3 of these points. So the origin is going to be here. Okay, I'm going to plot the do dotted lines for the -x, -y, and -z. Okay, so we're going to plot the point -3, 1, 0. So -3 in the x direction, 1 in the y direction, and then 0 in the z direction. So that's going to be here. Okay, -3, 1, 0. We can connect those. Now we can draw 1, 0, 1. So 1 in the x direction, 0 in the y direction, 1 in the z direction. So that's going to be located here. I'm going to change this to green, just so it pops a little bit. Okay. And this, even though it's not our normal parallelogram or rectangle that we draw planes with, this plane is going to be in this direction and it's going to extend in all directions. So, you know, obviously like this plane can be drawn forever and ever in all directions, but this is the angle it's going to be on, okay? And it's going to be represented by this triangle. Okay, example 6. Sketch the plane defined by the equation 2x plus 3y minus z equals 4. So if we brought this 4 over, we would have 2x plus 3y minus z minus 4 equals 0. Okay, and in this case, this is case 3 where d does not equal 0. So none of the coefficients equal 0. So we have an a, b, and a c value, which is 2, 3, negative 1. Okay, and we have a d value because d does not equal 0. So we have a negative 4. What we're going to do in this case is just simply find the 3 intercepts and then draw a plane through them. So again, 3 intercepts, our plane is going to look like a triangle again. Okay, so let's find the x-intercept. So the x-axis is going to be in the form x, 0, 0. Okay, then we're going to find the y-intercept. And that's going to be in the form 0, y, 0. And then the z-axis, and that's going to be in the form 0, 0, z. Okay, so we take this equation. So if we had 2x plus 3y minus z minus 4 equals 0, the y and the z are going to go away. We're simply going to have 2x minus 4 equals 0, 2x equals 4, and then we're going to divide out. Okay, so we got divided by 2, we get x equals 2. So the point we have for this one is 2, 0, 0. Okay, what about the y? So for the y, if we had 2x plus 3y minus z minus 4 equals 0, there's going to be a 0 plugged in for the x and a 0 plugged in for the z. So those are going to go away. We're going to have 3y equals, I'm going to bring this back over, 4. Okay, so we have y-intercept of 4 over 3. Okay, that's going to be in the form 0, 4 over 3, 0. Okay, and now the z-axis, again, 0, 0, I'm going to go negative z minus 4 equals 0. I'm going to bring over the negative z this time so that it becomes positive. So z equals negative 4. So this is going to be in the form x, y, z, 0, 0, negative 4. So let's go ahead and draw the positive x, y, and z axis. So x, we have y, we have z. Okay, and let's plot 2, 0, 0. So 2 on the x-axis and 4 over 3, so that's like 1.3, right? If you divide it in your calculator. Okay, 1.3 or 4 over 3 on the y-axis. And then on the z-axis, negative 4. So that's actually going to be down here. Okay, and that's our plane. Okay, example 7, determine 2 direction vectors for these 2 planes. Okay, so we have plane 1 and plane 2. So let's go ahead and determine for plane 1 where it intercepts the x-axis. Okay, so let's go x-intercept. So for the x-intercept, we're going to get some number x and then 0, 0. So we're going to have 3x. The 4y is going to go away, and then it's going to be equals 12. So we're going to get x equals 4. Okay, so we have the point 4, 0, 0 for like the x-intercept. Now we're going to do the same thing. We're going to do what is the y-intercept. Okay, and of course this is 0, y, 0. So the x is going to go to 0, and we're going to have 4y equals 12. Okay, so y equals 3. So we know that the y-intercept is 3. Okay, so now what we're going to do with these 2 points is we're going to find a direction vector. Okay, so it is going to be, let's go, you know what, let's go direction vector y, like, well, if we call this y and x. So we're going to go 4 minus 0, because I like that leading coefficient as positive. 0 minus 3, so we get negative 3, and 0 minus 0, 0. Okay? So, as we can see, we have, let's change color. We have 0z in the equation. Okay, so we got to think about what that means. It does not intersect the z-axis. Okay, or else we would have been able to sub in 0 for x, 0 for y, and then solve for z, but we don't have that z, so cannot do that. Okay, so what we're actually going to have is like a second direction vector, and it's going to be in the form 0, 0, 1. Essentially, it's in the form 0, 0, z, as long as z does not equal 0, right? Because, again, direction vectors scalar multiples, so we just can't lie on the z-axis. Okay, now let's try plane 2. Okay, so we're done plane 1, plane 2. X minus y minus 5z equals 0. Okay, so we have x minus y minus 5z equals 0. Okay, so we got to think about what kind of plane this is. So we have an x, y, z, and then we have d equals 0, right? So because d equals 0, we have the point 0, 0, 0. We know that this goes through the origin. Now let's find 2 more points. So we'll do the xz plane. Okay, and then this is when y equals 0. Okay, so let's set up this equation. So we'll have like x will not include y, so we're going to have x minus 5z equals 0. In other words, x equals 5z. So we're going to substitute a point in for x or y. Well, if we, or sorry, x or z. If we subbed in 1 for z, we're going to get 5 for x, and that's going to be another one of our points. Okay, and now let's try maybe like the xy plane. Okay, and this is when z equals 0. So come up here, z equals 0. What's going to be our equation? X minus y equals 0, or in other words, x equals y. Right? These are our equations. So we know our z is going to equal 0, and anything that we have for x, y is going to be the same. So we can have 1, 1, 2, 2, 3, 3, so on. So by choosing the point 1, 1, we're able to have that in like the lowest terms. Okay, and now back up to what the question is originally asking. Determine 2 direction vectors for each plane. So one of the direction vectors for this plane will be, let's call this ABC for simplicity. Okay, it'll be vector AB. Okay, so we're going to go 5 minus 0, 0 minus 0, 1 minus 0. That's easy. It's almost like those points turn into the direction vector. Okay, we've seen that before. Okay, and now direction vector AC. In other words, our second direction vector, we're going to go C minus A. So 1 minus 0, 1 minus 0, and 0 minus 0.